Alright, in this lesson, we are going to learn about logarithmic functions. So finally, we're getting to what this chapter is really about. You've learned exponential functions, now we're going to talk about how they're related to logarithmic functions. So some of our objectives here are to convert exponential to logarithmic, so they're related, evaluate logarithms without using your calculator, then evaluate some using your calculator, and finally find the inverse of these functions, and we're going to discover something really neat with that as well. So first, what is a logarithm? A logarithm gives us the ability to solve for x, especially when x is in the exponent. So one example of this is especially when x is in the exponent. So like 2 to the x equals y. We're going to be able to solve something like that. So first, let's talk about what a log looks like. They're inverse of variable exponents. So basically, a logarithm is an inverse of an exponential function. Logarithms allow us to rewrite an equation so that there is no longer an exponent. So again, going back to that ability to solve for x. So a log basically looks like log base b. So we call that the base of some value, so I'm going to call that a, and that is our value that is going to be the answer, is equal to x. So it's equal to x, and think about x as the exponent. Well, how does this relate to going back to exponentials? Well, we can have our base b raised to the power x equal to our answer a. So that's where the answer a comes from. So base raised to some exponent is equal to the answer. So again, to reiterate here, b is your base of exponent and log. A is your answer, and x is your exponent. So logs can be also written without a number for a base. When a log is written, so specifically a log without a number for its base is base 10. Excuse me. Now, that's the common log. So log base 10 is the common log. We talked about that already in exponentials. When the base is e, that is represented differently. We call that the natural log. So the natural logarithm. Well, the natural log is represented, again, when e is there, and we use the letters ln. Never, ever call it ln. It is the natural log. So if you see this, you have to say natural log. Alright, so that's kind of the basics. Let's put this all into how we convert here. So first, we're going to write logarithm conversions, and we're going to use conversions to help us change the format. The way I like to think about this is if we start with log base b of a equals x. Always start with the base. So start with the base to some exponent. So let's flip here. Base to an exponent is the answer. And flipping the other way, we're going to start with a log base b of some number is equal to the exponent. So that's the way I think about changing these, rotating around. So talking about example 1 here, the base, so the base of the exponent raised to the 3rd power is equal to 125. So changing it around, base to exponent equals. Same thing here. We're going to go base, so this is our base of something, but now we're at a log. So we have a log base 4 of 4096 is equal to 6. So again, at this point in the video, if you think you got it from changing around, try these two, pause, and then go ahead and try them, and then check them. So I'm going to go ahead and do them. The base j to some exponent m is equal to 15. And again, converting here, we have our base. So base 6 log base 6 of h is equal to z. Okay, so moving on now. Just a few more examples. Again, no base here, so that's 10. So I'm going to rewrite this as log 10 k equals 15. I'm going to let you convert that and finish that one out. So no base equals 10. If you see an e again goes with the natural log. So base ln, natural log, I made the mistake, not supposed to say it. Natural log base e, well we don't have to write that base e, of y is 7. And again, here, this one you have to think of it, natural log goes with base e. So there's an e there, so I'm going to write this, and then go ahead and switch. So e to your power gives you 5. So e to the power z equals 5. Alright, now that we have switched between forms, let's go ahead and actually evaluate some logs. So hitting another objective here. The first thing you want to do when you evaluate a logarithm is convert. So first, convert, and then we need to do some guesswork. Find an exponent that makes the equation true. So here we've got 3 to some power